Hello everyone, you are listening to Uncomfortable Truths with Euclid Phoenix, where I talk about politics, religion, and other BS that I find interesting. Today, for other BS, we will take a look at theory of relativity and the double slit experiment. Now, when most people hear relativity, they think complicated equations, advanced physics, something they'll never really understand. But the core idea is actually simple. The way we experience time and space depends on motion and gravity. Part 1. Time isn't absolute. Let's start with something we all assume is true. Time is consistent. A second is a second, a minute is a minute. But relativity says that's not true. Example, imagine two people, one standing still on Earth, one traveling in a fast spaceship. From your perception on Earth, the person on the spaceship experiences time more slowly. This is called time dilation. Part 2, motion changes time. The faster you move, the slower time passes for you relative to someone else. Important detail, you wouldn't feel it. Everything around you would seem normal. But to an outside observer, your clock is running slower. The extreme case, if you could travel the speed of light, time would effectively stop for you. But here's the catch. Only things with no mass, like light, can do that. Part 3, gravity also changes time. Now let's make it even stranger. It's not just speed that affects time, gravity does too. Example, a clock near Earth, a clock far out in space. The clock closer to Earth ticks more slowly. Why? Because gravity affects the structure of space-time. Part 4, space and time are connected. Before relativity, people thought space was one thing, time was another. Einstein's insight, they are part of the same system, space-time. What that means, you can't change space without affecting time. You can't change time without affecting space. Part 5, why this matters. This isn't just theory. Relativity affects real life. Example, GPS. Satellites orbiting Earth move very fast, experience less gravity. Result, their clocks run differently than clocks on Earth. If we didn't adjust for this, GPS would be inaccurate within minutes. Uncomfortable truth. Here's the uncomfortable truth. Time is not universal. There is no single now that everyone shares. Part 6, the bigger implication. If time depends on motion and gravity, then reality itself depends on perception. Example, two observers can measure different times, experience events differently, and both are correct. Final summary. Let's bring it all together. Time is not constant. Motion slows time. Gravity slows time. Space and time are connected. Reality depends on perspective. Closing thought. So the next time you look at a clock, remember, it's not measuring something universal. It's measuring time from your perspective. Part 2 of other BS. The double slit experiment, when reality stops making sense. Let me start with something that sounds impossible. A particle can act like a wave until you look at it. And when you look at it, it changes its behavior. Not metaphorically, not philosophically, physically. This isn't science fiction. This is one of the most famous experiments in physics, the double slit experiment. And once you understand it, it becomes very hard to think about reality the same way again. Set expectations. Now this experiment has a reputation. People hear about it and think it's too complicated, it's abstract, it's impossible to understand. but the setup is actually simple. The implication, that's where things get strange. Part 1, the basic setup. Imagine this. You have a wall with two narrow slits, a screen behind it, and something you're firing at the wall. Let's start simple. Case 1, solid objects. If you throw something like tiny pellets at the wall, they go through the slit, one slit or the other. On the screen behind it, you see two clear lines, one of each slit. Not surprising. Case 2, waves. Now imagine you send waves, like water waves, through the slits. Something different happens. The result is the waves spread out and overlap. This creates a pattern of alternating bright and dark bands. This is called an interference pattern. Key idea, waves don't just go through one slit, they go through both and interfere with themselves. Part 2, now use particles. Now here's where things get interesting. Instead of pellets or water, use electrons. Electrons are particles, so logically you'd expect two lines like the pellets, but that's not what happens. When scientists fire many electrons through the slits, they get an interference pattern. Let that sink in. A particle is behaving like a wave. The first weird result, electrons, individual particles, are somehow going through both slits, interfering with themselves. Even stranger, if you send the electrons one at a time, you still eventually get the interference pattern, meaning each electron isn't just going through one slit. It behaves like it goes through both. Part 3, let's observe it. Now comes the moment that breaks intuition. Scientists ask, which slit is the electron actually going through? So they set up a detector to observe it. Expectation. You'd think we observe it, we confirm it's a particle, nothing else changes. However, the reality is the interference pattern disappears. Result, you get two lines again, just like solid particles. The second weird result, the act of observing changes the outcome. What does that mean? Let's slow this down without observation. Electrons behave like waves. With observation, they behave like particles. So what changed? The setup didn't change, the slits didn't change, only the observation changed. Important clarification, this does not mean your mind creates reality. That's a common misunderstanding. What it actually means, observation in physics involves interaction. When you measure something, you disturb it. Part 5, wave-particle duality. This leads to one of the core ideas of quantum physics, wave-particle duality, meaning particles are not just particles. They exist as probabilities, waves of possibility. Before measurement, the electron is spread out, not on one fixed place. After measurement, it collapses into a specific location. The uncomfortable truth. Here's the uncomfortable truth. At the fundamental level, reality is not fixed until it is observed. Part 6, the deeper implication. This experiment suggests something profound. Reality is not as solid as it appears. Instead, at the quantum level, things exist as possibilities, not definite states. Only when measured do they take on a definite form. Part 7, what this does not mean. Let's ground this a bit. This does not mean you can control reality with your thoughts. The world is an illusion in a simple sense. Instead, it means the rule at the smallest level of reality are very different from our everyday experience. Part 8, why we don't notice this. In everyday life, objects are large and our actions are constant. And the result, quantum effects average out. So we see stable, predictable reality. Final summary. Let's bring it all together. Particles can behave like waves. They can interfere with themselves. Observation changes their behavior. Reality at the quantum level is probabilistic. Closing thought. So the next time you think of reality as solid and certain, remember, at its most fundamental level, reality is something that only becomes definite when it's observed. Thank you for listening to this podcast. Feel free to check out my website and the notes. I also have a link to my Patreon page if you want to financially support me, as these podcasts take a lot of time to put together. Every dollar counts. I hope you have a nice day.